Hello, everyone. Mr. Minnick is my name. Math is my game. And on today, with my um, sixth period Algebra II, we're going to be talking about Wyndham and West Virginia. No, I'm just teasing. I always say that. I shouldn't say that. It probably offends people out there. But we are talking about things that are related. We are talking about families of functions. Families of functions. So really a cool lesson. It sets the foundation for graphing anything that we're going to be graphing for the rest of the year. So the skills from this particular lesson are skills that should be retained and devoted to memory and not forgotten. The objectives, the goals, by the end of this lesson, what you should be able to accomplish is you should be able to know, and when I say know, I mean graph without a calculator, without any notes, graph three parent functions. Graph three parent functions. So we're going to be looking at three parent functions. Additionally, you're going to need to know the three types of transformations. Okay. Three parent functions, three types of transformations. And what's weird is each type of transformation actually has two parts to it, two components to it. So I promise that I will make this as painless as possible. I promise I will do my bestest to make this make perfect sense. So I guess we'll just go ahead and get started. Here we go. Parent function number one. Parent function number one. Parent function number one. Y equals f of x equals x. That's our parent linear function. That is our parent linear, L-I-N-E-A-R. That's our parent linear function. It's a pretty cool one. Real easy to graph. Some people like to make a table of values. It's probably not a bad idea if you're not sure how to graph something. So if we think about our table of values, our x value and our y value are actually going to equal each other. So if you pick 0 for x, y is going to be 0 also. If you pick 10 for x, y is going to be 10 also. You only need 2 points to make a line, so we'll go ahead and wrap this one up. Get the right line types. There it is. That's what it looks like. If you took Algebra 1, which I'm assuming all of you did, you should be able to graph that pretty easy, right? Let's think about the slope. What's the slope of this thing? Anybody? The slope's 1, nice. And the y-intercept, or the b value as it were, 0, 0, 0, yeah, it goes through the origin. All right. So that's one of three parent functions that you need to know. The parent linear function, y equals f of x equals x. How are we doing so far? Good? All right. Next parent function, in no particular order. Parent function number 2. Picked a heck of a time to get the coughs. Let's see if the water helps. So this absolute value parent function, absolute value parent function, some of you have probably seen it. Last period when we looked at this, when somebody was really gung-ho about this, they said, oh, I know what that one looks like. That one looks like you. A U. This one actually doesn't look like a U. Does anybody remember what this one looks like? Similar to a U, it looks like a V, actually. So it actually looks like a V. So again, with the table, I'm not a big fan of tables, but this is pretty easy. Our Y values are going to be the absolute value of our X values. So if you pick -10, the Y value is going to be +10. If you pick -5, the Y value is going to be +5. Try that again. If you pick 0, the absolute value is 0, 0. Absolute value of 2 is 2. Absolute value of 8 is 8. So with this one, it's pretty clear, I hope, to see that this one has this V shape to it. Now what's going to happen on Wednesday's lesson is we're going to be taking these and we're going to graph these without calculators. The quiz, you'll be allowed to use one, but next week sometime there's going to be another quiz or maybe a unit test, and I expect you to be able to graph these without using a calculator. So there's a couple parts of this that we need to talk about. The lowest point of the graph, anybody remember the V word? Nice, good, vertex, awesome, the vertex. So the vertex of this particular function is located at the origin. One thing interesting about this particular function is the graph. If I were to take this right arm of it, if you would, and I clone that right arm, and I kind of flip it over from left to right, you'll notice that this graph is symmetrical around the y-axis. That'll kind of have a little bit of bearing on something we see later on. So that's the absolute value function. How are we feeling so far? Okay? Good. Good. All right. Well, the third and final parent function that we're going to look at today, parent function number 3, y equals f of x equals x to the squared, x squared. Dang it. X squared. So this one is our quadratic function. This is quadratic. A few years ago, my nieces wrote a rap about me. They called me King Quadratic. I'm so mathematic. It was pretty funny. So the parent quadratic function, again with this table of values, x and our y values are found by squaring our x values. If we square 0, we still get 0. If we square 1, we get 1. This is weird. Just about every single one of these goes through 0, 0, and 1, 1. If we square -1, we also get 1. Huh. Interesting. Anybody know what happens when you square 2? We get 4. So we go through the point 2, 4. And then when we square 3, what do we get? We get 9. We get 3, 9. So the cool thing about this one, similar to that last one we said was symmetric. That last one was symmetric about the x-axis. This one is too. And I probably made that arm or that branch a little bit too wide, but that's okay. So I'm just going to flip that around, flip that from left to right, and there we go. So I'll bet you could tell me what shape this one is. I'll bet you could tell me what shape this one is. So we describe this as being U-shaped. We describe this as being U-shaped. A real common mistake people make in graphing these is they want to make these straight line segments like this, and that's not the case. If you graph one of these on a graphing calculator, it's pretty clear that they are, in fact, U-shaped. There is a smooth nature to the curve. It kind of reminds me of myself in my younger days when I used to be smooth. Anyway, parent function number 2, the absolute value function. Parent function number 1, the linear, and parent function number 3, the quadratic. How did we feel about those 3 things? Would you be able to graph those next week if I gave you those on a quiz without a calculator, without notes? Well, I guess if I did that, it would be a test, because you're allowed to use your notes on just about all quizzes in here. So, All right, well, before we look at the next thing, I want to go back and look at the objectives. It says you're going to be able to know 3 parent functions. Well, we saw the 3, so that's all right. The next thing is to know the 3 types of transformations. Oh, man. I better do something about this tooth. It's killing me. I don't know if I told you guys about this or not. I had this tooth, started hurting the other day. I called the dentist to try to get it looked at. The only time they could get me an appointment is 2:30. They couldn't get my appointment until 2:30. So, anyway, transformations. Transformations. There are 3 types. I'm going to use Roman numerals when we talk about these. And the first type of transformation that we're going to talk about is something that when I was an athlete back in the day, if you could believe that, about 100 pounds ago, I used to be in pretty good shape, and I used to have a pretty decent vertical leap. So we're talking about vertical things, vertical blanks and vertical blanks. Not lines. So what happens if your muscles are tight and you need to warm them up? You stretch. So we're going to be talking about a vertical stretch, and then the other one reminds me of bicyclers. You ever see those shorts that the bicyclers wear with that they put on their thighs? What kind of shorts are those called? Those real tight spandex ones. Compression shorts? So in geometry, you probably learned the word dilation. And in Algebra II, sometimes there's different words that mean the same thing. So if you're familiar with the dilations, the language we use here in Algebra II is stretches and compressions. Now keep in mind we're transforming functions. Our function is going to be f of x. And if we want to take our function and we want to make it stretched out, that's going to make it taller. So a stretch, if we want to think about it, a stretch is going to make the thing look taller. A compression is going to make the thing look shorter. Sometimes when things look taller, they also look narrower. When things are shorter, they look wider. So you got to kind of be careful with which language you use. But anyways, regardless, when we do this, we're going to be taking f of x and we're going to be multiplying it by some unknown constant number. That's what we do. We just take the function, however the function's defined, we multiply it by some number. So I've got this parent parabola graphed, right? What I want to do is I want to leave that blue one and I want to add another graph here. I'm going to multiply that by 3. I want to make that 3x squared. Now let's see if this makes this thing taller or shorter. 3x squared. Did that make it taller or shorter? How does the red one compare to the blue one? How does the red one compare to the blue one? The red one, does it look taller, narrower, or shorter and wider? It looks narrower, and so it is taller. And so the red one there is what we call a vertical stretch. Okay? What I'd like to do is look at a table of values. I'm going to press Control-T on my calculator. And what I'd like you to do is I'd like you to look at how the y values on these compare. I don't know if you can see them or not. My calculator's acting the fool. There we go. Here we go. I think I kind of have that. My calculator doesn't like me today. Let's see if I can cut that out. Capture that. So what I want you to try to notice is how do the y values compare in that stretch? The one y value is 1, the other one's 3, the one's 4, the other one's 12, and then 9 and 27. Do you see how those y values are tripling? Okay. So what we say then is these vertical stretches happen when our K value is a certain size. How big do you think K has to be in order to stretch something out? Greater than 1, nice. Good. When our K value is bigger than 1, that's when we have one of these vertical stretches. Okay? So just to kind of be clear on what we're talking about, vertical stretches, the graph looks taller. Well, the graph is taller. The graph looks narrower, and our K value is bigger than 1. Okay? So maybe I'll put these headings here. The graph, the Y values are taller. The graph looks narrower, and our K value is bigger than 1 whenever we have a vertical stretch. So far, so good? Okay. Well, what if we pan to the right? What if we look at these vertical compressions? The graph's going to look shorter, the graph's going to look wider, and our K value is going to have to be something else. So my graph doesn't get too cluttered, I'm going to go back and get rid of that red one for now. What do you think I'm going to have to multiply this graph by to get some kind of compression? Rather than a number that's bigger than 1. A number that's smaller than 1. Number that's smaller than 1. So what's a number smaller than 1? Negative something? Okay, what do you want to try? Negative 2? Well, that's bigger than 1. So what do you want to try? Just negative 1? Okay. Oh, man, that flipped the thing over. That didn't make it shorter. So I guess that's not going to work. I guess that opens up another can of worms. I guess that opens up our third kind of translation. Magic mirror on the wall. Huh? What's 2? Well, we didn't get to 2. You guys picked the negative 1. You don't like going out of order. All right. So maybe we shouldn't have picked a negative number. All right? So maybe we shouldn't have picked a negative number. So what's a number smaller than 1? Yeah. 0.5? Well, decimals don't exist till chapter 7. 0? If we have a 0, we have a horizontal line. That's not a parabola. Oh, a fraction. So 0.5 is a fraction. But what about 3/4? Would that work? Maybe. Bueller. There's 44. Okay, so 3/4. So compare the red one to the blue one. Does it look wider? Is it a little bit shorter? Okay, so now we got this thing cooking. So here, our K value is going to be between 0 and 1. I don't know why people have such a hard time with that interval. Probably because there's more numbers between 0 and 1 than there is in all of infinity. And that's another lesson, another day. So you might want to highlight that in some way. And on all of these, for all these transformations, I probably ought to say that we're going to assume that K is positive. Okay, I probably should have said that right off the get-go. We're assuming that K is positive for all these transformations. K can be any real number it wants to be. It can be 2, 3, 3/4. It can be any real number, but it should be positive. So if I go back to that graph again and look at my table, let me insert my table again. You'll notice what happens with my Y values here. Maybe. There we go. Why does it always do that? Come on. Let's go. Do you see how my Y values compare? 1 to 3/4 and 4 and 3. You see how those compare, how they're smaller? Okay. All right. Are there any questions, comments, concerns, short debates or long debates about vertical stretches or vertical compressions? Well, we still got two more types of transformations to talk about. And you didn't want to jump to 3, huh? All right, well, guess we'll go to the next one then. Guess we'll go to number 2. So I'll put transformations continued. And again, we're going to assume that K is positive. We're assuming that K is positive. So the second type of transformation then reminds me of that one movie. And I'd never even seen the movie. Madagascar, you guys seen that movie? There's this one song from it. What do you like to do? I like to move it. So some people think of this as moving. Moves. I got moves. Well, that's what it is, but that's not what we call it. We call these vertical or horizontal. Maybe this will help. Como se dice the bathroom? How do you say the bathroom? Warum wirst du so sauer? Why are you so mad? 1, 2, 3, 4. 1, 2, 3, 4. What am I doing? Translating. These are called vertical translations. A vertical translation and a horizontal translation. Okay. So this is the second type of transformation, translating something, which is essentially just moving it. The interesting thing about this type is it's going to retain the same shape. It's going to retain the same size. The object, the function, the relation, whatever it is you're dealing with is just going to be located in a different spot. So this happens when we take f of x and we do something to it. Something with k. How are we going to modify f of x with our k to take something and translate it up, let's say? What do you think? I heard somebody say it. We're going to add. So if we add a k value, it's going to essentially, it's kind of cool what happens. Let me see if I can highlight this. So vertical translation is when we add k to the end of a function. When we add some number to the end of a function, all that's doing is taking our y values and increasing them. It's not multiplying our y values, but it is increasing them. It's going to make all our y values go up. It's going to shift the whole function up. Let's see it on our parabola graph. Let's see it on our parabola graph. Maybe. So on my parabola graph, I want to take this x squared that I had, and I want to translate the thing. Let me just put a plus 1 at the end, a plus 1. How does that red one compare to the blue one? Is it the same shape? It might not look like the same shape, but let me zoom out a little bit. Let me zoom out a little bit from here. Is it the same shape? It actually is. If I were to superimpose it on the other one, it would be the same shape. Is it the same general size? They're the exact same width, but how's the red one compared to the blue one? It's translated up, k units. Okay, so this, oh man, I just dropped it. So this translates the thing up, k units. Vertical translation. How are we doing so far? Does this make sense up to this point? Does it? Well, I got to be honest with you. I got to be frank with you, even though that's not my name. If I'm being frank with you, this next part's not going to make sense. Got to keep them separated. So when we look at a horizontal translation, we need to do something with f of x. And we want to be able to translate the thing either to the right or to the left k units. Now, just to be consistent, we've been adding k or multiplying by. We're going to go ahead and add k, but watch what happens here. Watch where this k is being added. Do you see how it's being added inside the parentheses now? For a quadratic function, we're going to have parentheses. For an absolute value function, inside the parentheses means inside the absolute value bars. Does that make sense? If we have any other kind of function, it's going to be like if it's a cube root function, it'll be under the cube root. So this might come as a big surprise to you. Watch what happens if in parentheses, I said in parentheses, I go ahead and I add 4. Which way do you think that's going to take the blue function and move it or translate it? 4 units to the right. That's what you'd think, isn't it? However, it translated at 4 units to the left. So weird. So when we add something, it's actually going to translate it left. I'm going to highlight that. I'm going to put an asterisk by it. So with these horizontal translations inside the parentheses, when we add some positive k value, it actually translates a thing to the left that many units. There's special language that we like to use in this course for that. When it's the opposite of what you think it is. Thinking is called intuition. And when you think, it's intuitive. And when something is the opposite of what you expect, it goes against everything that you believe. We say that this is counterintuitive. It goes against what you believe. We call this idea counterintuitive. Now, of all the different transformation types, this is the only one that's like that. Vertical translations, you add something to the end, it goes up. You subtract something at the end, it goes down. With stretches, if you multiply by a number bigger than 1, the thing gets taller. It stretches out. If you multiply by a fraction, it squishes the thing down. It compresses it. All that makes perfect logical sense. But the right and left thing, that doesn't make logical sense. And maybe we'll answer the question why that's the opposite of what you'd expect later this week. Probably on Wednesday or Thursday. Any questions, comments, concerns, short debates, long debates so far? Would anybody like to give a shout out to anybody in my other classes? No shout outs? I'd like to give my 7th period class a shout out. I'd especially like to give a shout out to the future Mr. Minnick for being so awesome. Tell who they're going to get it done today? Going to get a dub today? Cage, we're going to get a dub today. Okay, I don't get the inside joke, but I'm sure Cage does. All right, I'm about to switch microphones here because my other mic's dying. I got 2 turntables and a microphone. But where it's at. Okay. And that's how we have a backup. All right, well, if there's no other questions and no other shout-outs, the third type of transformation has to do with magic mirror on the wall. Who's the fairest of them all? Did I just say magic mirror on the wall? Didn't you always think it was mirror, mirror on the wall? It's magic mirror. If you don't believe me, that's the Mandela effect. It's magic mirror on the wall. Just like Luke, I am your father. Darth Vader did not say that. He said, no, I am your father. You don't believe me? I'm telling you, look it up. It's the Mandela effect. If there's time at the end, we'll look. So anyways, these things are called reflections. These last kind are called reflections. And again, we're talking about transformations. And I'm going to go ahead and put CONCL, concluded. This is the conclusion of our translations. And again, we are assuming that k is greater than 0. Well, actually, we don't even need to assume about k because we're not even going to use a k here. So we've got two different kinds of reflections. We've got a reflection about, in this context, about means around, across, over, about the x-axis and about the y-axis. Okay, so we're going to be reflecting things about, around, or across the x-axis or the y-axis. Anybody think they know how to take something and essentially flip it from, well, let me just draw a picture. They say a picture is worth 1,000 words. Suppose we had this parabola that looks like this, and I wanted to go ahead and flip it from up to down, and I want to make this one translucent. There we go. So how am I going to do that? What am I going to do to the function f of x if I wanted to take the thing and flip it over? If I wanted to make all my y values negative? Do what? Make it negative? Make what negative? The whole thing, right? Make the whole thing negative. Bam, there it is. Our y values come from the f of x. So we just stick a negative in front of it, and that's it. That does it. That does it. That's it. That's it. Well, I'm going to put up a big border. You got to keep them separated. I know I've said that already once. I'm going to put up a border to separate these. Okay. So this last one then, if I wanted to flip something around the other way, so if I had something that does this, I'll go ahead and clone that. I said I'll clone it, and then I'll make it translucent. And if I wanted to flip it from left to right now, flip from left to right, so I wanted to make it go over here like that, what am I going to have to do to my f of x here to reflect it across the y-axis? Anybody know? I still need a negative sign, but it's weird where it goes. I want to take all my x values and make them the opposite of what they were. So where do I put the negative sign? Inside the parentheses right in front of the x. Does that make sense? Okay. So on Friday's quiz, there's going to be a question that's going to say, okay, hotshot, describe the 3 types of transformations. Be sure to discuss what kind of k values you're going to have. K is positive. If k is bigger than 1 and you multiply a function by k, it's a vertical. You get the idea, right? That's going to be a 15-point question on Friday's quiz. All right, well, here we go. We got 3 examples to get to, and then we're done. Example number uno. Example 1. Describe the types of transformations. Oh man, ran out of room. Describe the type of transformations. Describe the types of transformations of y equals 2 times the absolute value of x minus 3 in absolute value plus 5 from the parent function, from y equals the absolute value of x. Now you could graph this, but if you understand what we just spent the last 30 minutes talking about, you'll be able to answer this. Let's take a look at each thing, one by one by one. What the heck does this 2 do? What's that 2 tell us? Because of the 2, what do we got? A vertical stretch by a factor of how much? Vertical stretch by a factor of 2. Just to say it's a vertical stretch isn't good enough. We do need to say, okay, it's a vertical stretch by a factor of 2. Okay. I feel like Vanessa Williams, I'm going to save the best for last. Let's look at this plus 5. Because of that plus 5 on the end, Because of that plus 5 on the end, what's going on here? Yeah. Up 5. How do we say up 5 using the appropriate language here? What kind of translation? A vertical translation. Vertical translation up 5 units. Okay? Good. And last but surely not least, and my name's not Shirley, and your name's not Shirley. Maybe you have a cousin named Shirley. What is that? Oh, I forgot to highlight it. What is that? I forgot to highlight it again. Where's my highlighter? There it is. What does that minus 3 in the parentheses tell me? It's a what? It goes to the right 3. So how do we say it goes to the right 3? It's a horizontal translation right 3 units. When we see that minus 3, we might think it goes to the left 3, but remember the right left is the opposite of what we think. Now, for those of you who are wondering, well, what about a reflection? Did we stick a negative in front of the x? Nope. Did we stick a negative in front of the absolute value? Nope. To have a reflection, we would have had to have a negative in front of the x or a negative in front of the absolute value, which we have neither. Any questions about that example? Anybody want to give a shout out? I'm going to give a shout out to everybody who's not on their cell phone. And for those of you who are, shame, I know your name. Maybe I'll write you detention today for being on it. Okay, example 2, describe the transformations. Example 2, describe the transformations. Describe the transformations. Notice how I put in the apostrophe s, or that there could be more than one. There could be more than one. So I want to have some of these thingies on the end. I'm going to make this guy here. And I'm not done with the directions. I'll say, describe the transformations from line L to line M. So go ahead and clone this one. And I want to make this one a little bit different color. So maybe I'll make this one blue. And there we go. And I want to put it right there like that. So I'll call the one line L and the other one line M. Anybody think they got this one figured out? This one's too cool for school. Like, it can't be that difficult. Let's think about some equations for this. Line L is going to be y equals x, right? What's the blue ones? What's line M's equation going to be? Same slope. Y, the line M is going to be y equals what? X plus 4. Now, what's interesting is where you put the parentheses. If you put the parentheses around this x, what's that tell you about line M? It's a translation which way? Up how far? Up how far? Up 4. So we would say it's a vertical translation up 4. Everybody buy that? But what I want you to notice is look at the directions. Describe the transformations. Could we write this as y equals x plus 4 in parentheses like that? And if we did so, I want you to watch it. It's kind of hard to see this played back on the video. But what I'm going to do, is I'm just going to drag this red line. I'm going to drag it 4 units to the left. I'm dragging it for you. I got my finger right on the origin. I'm literally dragging my finger 4 units to the left. Isn't that weird? How when I drag something 4 units to the left, it's the same thing as dragging that line up 4 units? That's one of those anomalies about lines. So this is also a horizontal translation, left 4. Did you catch that little thing about the parentheses, how that worked? Question. In the final thing, would you write both? Yeah, for sure. If it's a line whose slope is 1, you do need to write both. And on tonight's exercises, one of them says, can you dream of a function that when you do 1 transformation, it's actually 2? There you go. Does that make sense? All right, one last thing then. Example 3. And this is it. We're done. Example 3. And then we get to go home. Write the equation of the graph. Write the equation of the graph. So just for reference sake, I'm going to look at the parent function. We know what it looks like, the parent quadratic. So the new one, I'm going to take this thing and I'm going to clone it, and I'm going to flip it. Oh, not left to right. I want to flip it from up to down, and I want to make it translucent. Here we go. And I want to put the thing over here. There we go. There we go. So we know that the parent function is y equals x squared. We know that our answer is going to have a y in it, it's going to have an equals in it, it's going to have an x in it, it's going to have a squared in it. Well, it looks like to me like the thing moved 6 units to the left. So where am I going to put the 6? What am I going to have to do since it translated 6 units left? Is that going to be a plus 6 or a minus 6? Plus 6 inside the parentheses, right? All right. Because the thing translated down 2 units, what am I going to do with the 2? Put a minus 2 where? On the end. And there's one more thing. This thing flipped over, didn't it? It reflected across the x-axis. So because it's a reflection about the x-axis, there's one more thing that's missing. The negative. Where's the negative go? In front of the x or in front of the parentheses? If we want to reflect it across the y-axis, we put it in front of the x. So we're going to put it in front of the parentheses, and that's it, right? What do you think? You got it? It's been real. It's been fun. I hope everybody has the best day of their lives. One last shout out to, who gets it? Cannon gets a shout out? Okay. Have a great day. See you. Good.